Hello, in this video we're going to look at the mathematics for business and economics dealing with the topic of single equations. The basic concept of working with and simplifying equations. Any operations performed on an equation must maintain the equality, the equal sign, which means the left-hand side of the equation must still equal the right-hand side of the equation after any mathematical operation. So let me give you an examples where this doesn't hold. So adding a number only to one side of the equation. So if we have an equation, the left-hand side equals the right-hand side. If you were to add a number only to one side of the equation, it would no longer be true that the left-hand side equals the right-hand side. So you just can't add plus 100 to the right-hand side. Subtracting a number from only one side of the equation will no longer maintain the equality between the left-hand side and the right-hand side. So if we were to subtract 50 from the left-hand side, it would no longer be true that the left-hand side equals the right-hand side. Multiplying only one side of the equation will no longer maintain this equality between the left-hand side and the right-hand side. If we were to multiply the right-hand side only by 10, doing nothing to the left-hand side, the equality will not be maintained. Dividing only one side of the equation will also violate maintaining the equality between the left-hand side and the right-hand side. Here I divide the left-hand side by 2. It will no longer be true that the left-hand side equals the right-hand side. Only squaring or taking the square root of one side of the equation will also be a no-no. The left-hand side will no longer equal the right-hand side if we're to only square the right-hand side of the equation. So what should we do? The key point is what you do to one side of the equation, you must do to the other side of the equation in order to maintain the equality. So let's look at some examples of maintaining the equality. Adding the same number to both sides of the equation, like in this case 15 to the left-hand side and 15 to the right-hand side, will maintain the equality. If we're going to subtract, we have to subtract the same number from both sides of the equation. So it's okay in this example if we were to subtract, say, 4 from the left-hand side and 4 from the right-hand side. If we were to multiply both sides of the equation by the same number, so 2 times the left-hand side will equal 2 times the right-hand side. And dividing both sides of the equation by the same number is also permissible. If we're going to square, we'd have to square both sides of the equation. The left-hand side squared will equal the right-hand side squared, or taking the square root of both sides. Note here, it's okay to multiply one side of the equation by 1. 1 times anything is just that anything. So 1 times the left-hand side is going to maintain the equality here between the left-hand side and the right-hand side. All right, so what I want to do now is just go through a number of examples of simplifying equations, working with just single equations here, many of which you will find in economics and business applications. So here we have an equation with 2 variables, p and q. We want to solve this for p. So we want to isolate the p term. So what I'm going to do here is I'm going to add 4p to both sides of the equation. So if we add 4p to both sides, on the left-hand side, we're going to now have 4p. And what about on the right-hand side? Well, minus 4p plus 4p will cancel on the right-hand side. So we now have this. The next thing I'll do is I'm going to subtract q from both sides of the equation. I want to get rid of q here, so I'm going to subtract q from the left-hand side. And if I'm subtracting q from the left-hand side, I have to do it to the right-hand side. So that'll give us 4p equals 40 minus q. The next thing I want to do, I want to isolate the p term. So we're going to get rid of this 4. One way to get rid of this 4 is divide both sides of the equation through by 4. So 40 divided by 4 and this q term divided by 4 leaves us with this result. And if we want to simplify, 40 divided by 4 is just 10. Moving on. Example 2, we got 20 minus 0.5q equals 5. Let's solve for q. So first thing I'm going to do is subtract 20 from both sides of the equation. So on the left-hand side, we got 20 minus 20, so that's just 0. And on the right-hand side, we're going to have 5 minus 20. So giving us this result here. Simplifying the right-hand side, 5 minus 20 is minus 15. We got a minus and minus, so they're gonna cancel. Or a way we can think about this is we can just simply multiply both sides of the equation by minus 1. So that'll leave us with 0.5q equals 15. And now let's just isolate to q by dividing both sides by 0.5. So 0.5 divided by 0.5 on the left-hand side is 1. And on the right-hand side, we got 15 divided by 0.5, and that'll just be 30. Moving on. Here's example 3. We have 20 minus 1/4 q equals 40 plus 3/2 q. We want to solve for q. So first thing I want to do here is I want to subtract 40 from both sides of the equation. So on the right-hand side, 40 minus 40 disappears. And since we subtracted 40 from the right-hand side, we must do it to the left-hand side. So 200 minus 40 is 160. Now we got this minus 1/4 q. Let's get this to the right-hand side. So in order to do that, we're going to add 1/4 q to both sides. So on the left-hand side, minus 1/4 q plus 1/4 q is just 0. Leaving us with this on the right-hand side. We're going to add the q terms together on the right-hand side. We can do this through a common denominator. So what I did here is I got using the common denominator 4. So to turn this denominator into 4, I have to multiply it by 2. And since I multiplied the denominator by 2, I have to multiply the numerator by 2. So 3 times 2 is 6, and 2 times 2 is 4. We can add these up now to get 7/4 q. And now let's solve for q. We can multiply both sides of the equation by 4/7. So 7/4 times 4/7 on the right-hand side is just 1. Leaving this on the left-hand side. So 160 times 4 is 640, and that's all divided by 7. So we get the answer here of q equaling 91.43. Moving on. Example 4. I just want to solve this for x. So we've got m, and we got this other variable p subscript x. We've got x plus 1/3 x. We want to solve this for x. So the easiest thing here to do is let's factor out x on the right-hand side of the equation. So on the right-hand side, I want to factor out an x term. Nothing happens to the left-hand side, so I factor out an x term to give us this result. So notice if we were to multiply x by what's in parentheses, we'd just get back the original p subscript x times x and 1/3 times x. And then the next thing I want to do, I want to solve this for x, so I want to isolate to x. Let's divide both sides of the equation through by what's in parentheses. So we're going to divide everything through by what's in parentheses. Doing that, we're going to get this result. Example 5. Q equals, well, this mess. We want to solve for Q. So the first thing I want to do is simplify up the right-hand side. So I'm not going to do anything with the 40 at first, but minus 1/5 times 10 is just minus 10/5 or minus 2. And then minus 1/5 multiplied by minus q is going to be a positive, in this case positive q divided by 5, or positive q/5. 40 minus 2 is 38. We want to isolate to q, so we're going to subtract q divided by 5 from both sides. So q divided by 5 minus q divided by 5 on the right-hand side disappears, so we're left with 38. And on the left-hand side, we have this result. Getting a common denominator here. What is q? Well, q can be thought of as 5q divided by 5. That's just simply q. And then 5q divided by 5 minus q fifths leaves us with 4q divided by 5. We want to isolate the q term again. We're going to multiply both sides of the equation by 5/4. Why 5/4? Because 5/4 times 4/5 on the left-hand side will just become 1. And if you do something to one side of the equation, you have to do it to the other. And we'll get q equals 38 times 5 divided by 4, which is going to be 47.5. Example 6, we want to solve this for y. So it's kind of messy here. We want to solve this for y. So first thing I did here was I'm going to multiply both sides through by y divided by 4. So you'll notice on the right-hand side, I'm multiplying the right-hand side through by y divided by 4, and I'm doing that to the left-hand side. And so what's nice is this y divided by 4, all divided by y divided by 4 is just going to cancel and become 1. So now we're left with this expression. The simplification I did next, moving it up over here, 8 divided by 4 is 2, so that's just 2y. And again, I said we want to solve this for y. Oops. So I'm going to divide both sides through by 2. So dividing the right-hand side through by 2 and the left-hand side through by 2, we'll get y equals x divided by 4. Example 7, we want to solve this equation for p. So we got this equation, and we want to solve it for p. So the first thing I do is I add 25 to both sides. I just want to isolate the p term, so I add 25 to both sides. So 25 then will disappear on the, minus 25 will disappear on the right-hand side, and we'll add 25 to the left-hand side. Next thing I do here is I'm going to multiply both sides through by 3. So 1/3 times 3 is just 1, so just leaving us with p. Then 3 times q is 3q, and then 3 times 25 is 75. Example 8. We want to solve this equation for k. Let's solve this for k. So I am going to subtract 20L from both sides. That'll give us this result. Just isolating the k term now. And now I'm going to divide both sides through by 10. So 1,000 divided by 10 is 100. Minus 20 divided by 10 is minus 2. And of course, I did that to the left-hand side as well. 10 divided by 10 is 1, so that's why we just got 1k. Example 9. Again, let's solve this equation for y. Somewhat of a mess here, but we're going to try to isolate the y terms. So the first thing I did is I multiplied both sides through by 100. So 100 times the left-hand side will just leave us with this result, and 100 times the right-hand side leaves us with this result. All right, the next step, I'm going to multiply both sides through by y raised to the 0.25 power. So y raised to the 0.25 power multiplied by the right-hand side, that will cancel, just leaving us with 100 times x squared. And then on the left-hand side, we're multiplying that by y raised to the 0.25, so we get this result. Following the rules of exponents, I'm going to just add up these exponents here. Get y equals y raised to the 0.5 power. And again, I want to isolate the y term. So in order to do that, I am going to square both sides. So y raised to the 0.5 squared is just going to be y. And then we got to square the right-hand side as well. Everything on the right-hand side. So the left-hand side simplifies to y. The right-hand side, 100 squared is 10,000. X squared raised to the second power is just x to the fourth. Example 10, another equation we want to solve for y. So here I kind of did this in two steps. I multiplied everything through by 100. So the 100 cancels on the left-hand side, but now the 100 appears on the right-hand side. Then I multiplied everything through by y. So y times y on the right-hand side will get rid of the y term, but y times y on the left-hand side is y squared. And now again, we just want to isolate the y. So we can take the square root of both sides to isolate the y term. So y squared, and the square root of that is just y. The square root of 100 is 10, and x squared, taking the square root of x squared, is just x. Okay, so rules of exponents, we're just going to multiply these 2 times 1/2 and 2 times 1/2. Example 11, solving for q. Subtracting 12 from both sides. The minus signs will cancel, or multiplying both sides through by -1 gives us this result. Multiplying both sides through by q. Q's will cancel on the left-hand side, but we got 12q. And now finally dividing everything through by 12. Q equals 1/2. Example 12, solving for q. Similar problem to example 11. Moving 9 over to the right-hand side by subtracting 9 from both sides. Multiplying both sides through by -1. Multiplying both sides through by q squared. Dividing both sides through by 9. 36 divided by 9 is 4. 9 divided by 9 is just 1. And then taking the square root of both sides, left-hand side and right-hand side. Q squared, taking square root of that is just q, and taking square root of 4, or 4 to the 1/2 power, is just 2. All right, here's example 14. We've got this one equation and one unknown. We want to solve it for L. So the first thing I'm going to do is I'm going to add 16 to both sides. -16 plus 16 cancels that 16 over here. And then 24 plus 16 is now why we got a 40 on the right-hand side. We want to capture or isolate the L terms. Let's subtract L divided by 12 from both sides. So that gives us this result. Let's get a common denominator. So common denominator here is 12. So 4 times 3 is 12. 4 times L is 4L. 4L divided by 12 minus L divided by 12 is 3L divided by 12. Let's multiply both sides through by 12 divided by 3. So multiplying both sides through by 12 divided by 3, that's just going to give us 160. Example 15, solving this for L. Let's first simplify the left-hand side. 10 times 8 is 80. 10 times negative L or minus L is minus 10L. Let's subtract 80 from both sides. So 20 minus 80 is why we got minus 60. And getting rid of these minus signs on both sides by multiplying both sides through by -1, we get 10L equals 60. And dividing everything through by 10, L equals 6. And example 16, x divided by 1/3 y equals 4. Let's simplify this, this mess on the left-hand side. We can do that by multiplying the left-hand side by basically 1, 3 divided by 3. But if we do that, you'll notice that this 3 and the 1/3 will cancel and the denominator just becoming 1. So you get 3x divided by y equals 4. Let's multiply the left-hand side and right-hand side through by y. Okay, so I'm just showing that here. Y divided by y will cancel, become 1, and we'll just get 4y on the right-hand side. So 3x equals 4y, dividing both sides by 3. X equals 4y divided by 3. So I solved this for x. Okay, I hope you found this video helpful.